guys. So this video is actually a throwback to algebra. I'm so excited to share this video with you. It is all stuff that we learned in algebra, and really I'm hoping that by watching this video you can just kind of reminisce and remember all of those amazing times that you had in your algebra class learning about lines. This video is kind of the important points from the linear functions that you learned in algebra, and it's going to set you up really well to carry on into the next lessons of geometry. So if you remember from algebra, there are really three main equations to represent lines. There's slope-intercept form, point-slope form, and standard form. First one is slope-intercept form. Remember, it looks like this, and the M stands for the slope, and the B stands for the y-intercept. So that means if you were to look at a line on a graph, and if you could look at that line and find that the slope was maybe 5 over 2, up 5 over 2, and that line had a y-intercept of 0, 3, which means it crossed the y-axis at y equals 3, then you could write that equation like this. Just like that. The next way that we can talk about a line is with point-slope form. Now, point-slope form is helpful if you don't have the y-intercept, but you have any other point on the line. You can literally use any point. You could use the y-intercept if you wanted, or any other point too. Now, this looks like this. We still have a slope, and it's y minus the y-coordinate of any point on the line. So pick a point and write the y-coordinate right there. The minus is going to make it end up looking like the opposite of whatever y-coordinate you pick. And then over here we have equals the slope and then x minus the x-coordinate of that same point that you picked. So this x sub c, y sub c stands for the x and y coordinate of any point on the line. So let's say that you have a line where the slope is down 3 over 2, or negative 3 over 2. And it's passing through this point of 4, negative 1. So the line is going through this point. That means that you could write the equation like y minus the y-coordinate. So we'd write y minus a negative 1. But if we're subtracting a negative 1, we can just say plus 1. Because if you subtract a negative, it's really like you're adding. That's what I mean when I say it's going to end up being the opposite. Because of that minus, it's going to make our negative 1 look like a plus 1, because you're really saying y minus a negative 1. Equals, your slope is negative 3 over 2, parenthesis, x minus the x-coordinate, which is 4. So if you don't have the y-intercept, you can pick any other point and use point-slope form. The last one is standard form. It looks like this. It's a little bit more difficult to relate standard form to features on the graph, but we mostly use it when we have two things combining to be a total. So for example, if let's say you have hats that cost $6 and shirts that cost $8, how many hats and shirts can you buy for a total of $48? You could write that out like this. You could say, well, if we let x be number of hats, and y be number of shirts, we could say $6 for every hat and $8 for every shirt. And that's going to combine to equal $48 total. So you have two things adding up to a total. That's mostly when we use standard form. Now, if you notice, two of these equations both really use the slope in them. And I mentioned if you can look at a graph and identify the slope. So let's just do a little recap on what it looks like to look at a graph and identify the slope. So if you have a line, remember that slope is rise over run. So what we're going to do is we're going to pick 2 points on the line, any 2 points. It doesn't have to be 2 points right next to each other. I could pick this one and this one if I wanted. I am going to pick this one and this one right here. And I'm going to think about how do I get from one point to the other? So to get from here to here, I would go up 1, and then I would have to go over 2. So if I go up 1 and over 2, that means my rise is 1 and my run is 2, so that would be my slope. Another situation you might run into is if the line is going down. So let's say I pick this point and this point. To get from there to there, I actually, in this situation, need to go down 2 and over 3. So my rise is actually a -2 because I went down 2. And my run is still over 3. So I would have -2 over 3. So there, my slope is -2 over 3. And this negative slope corresponds to the fact that my line is going down and has a negative slope. Now, we also learned a lot in algebra how we can go from one equation to another, like one form to another. So let's look at point slope form, and let's say you wanted to know what the y-intercept of this line is. That means you'd have to change it from point slope form here, this one, to slope intercept, that one. So this is what our goal is going to look like. We have y equals mx plus b. That's the form that we want this to look like. So when we're changing this into our goal of this, we need to look to see, we're just going to do things to this until it eventually looks more and more like this one until it finally looks exactly like that form. So the first thing we notice is that over here we have parentheses and over here we don't. So to make this look more like our goal, let's get rid of the parentheses. To do that, we're going to distribute. So I'm going to take this 2 and multiply it by both of those. So now I have y minus 6 equals 2x plus 8, because 2 times x is 2x and 2 times 4 is 8. Now, I'm going to notice that over here, I just have a y all by itself, but over here, there's a minus 6 with my y, so I need to get rid of that minus 6. So now what I'll do is I will add 6 to both sides. So now I have y equals 2x, and then I can take this plus 8 and plus 6 together, and I get plus 14. Now this equation is in the same format as that equation, so I know that my slope is 2. And this graph, if I were to graph, it would actually cross the y-axis at 14. So with a little bit of algebra math magic and rearranging and maneuvering, we can easily change point slope form into slope intercept form. We can do something very similar if we have a standard form equation. We can change that into slope intercept form also. This is still our goal. Notice that here the y is all by itself. So our goal is to get this y all by itself. So first let's get rid of the 3x, because you always undo the things being added or subtracted to the y term first. We have this positive 3x, so we're going to subtract 3x on both sides. So that goes away. We're left with a 4y. And then because over here my x term comes first, just kind of keep it so it's looking more and more like this, I'm going to write my x term first. So I'm first going to write negative 3x, and then I have this positive 20. So it looks like that. Now, if you notice, the only thing left to do is here the y is all by itself. Here it's not. It's being multiplied by a 4. So I'm going to divide to get rid of that 4, but I have to divide on both sides. So now I have y equals, and I'm going to divide both of these terms by 4. So negative 3 divided by 4 does not turn out to be a nice whole number. It's a decimal. So I'm just going to keep it as the fraction negative 3 over 4x. And then 20 divided by 4 is 5, so plus 5. So that means if I were to graph this function, the slope would be negative 3 over 4, and the y-intercept would be 5. I hope this video was helpful. I hope it brought back lots of wonderful memories of algebra and lines and all of that good stuff, slopes and graphs. I hope that you enjoyed it, and if you have any questions, please feel free to email me or stop by our Google Meet and I can answer those for you. Otherwise, go ahead and try the practice. Thanks, bye.